Okay, in this video we're looking at the quotient rule, and it's a way to differentiate quotients. Quotient is a fancy name for fraction. So if you've got something that looks like a fraction, you're probably going to be using the quotient rule. It looks kind of like the product rule. Just as a reminder, the product rule looks like u dash v plus uv dash, and it looks almost exactly the same because the top of this fraction is literally the same, just with that minus sign sitting there, and then you just divide out by v squared. So it's important that you get u and v the right way around, but once you do that, it's pretty similar to the product rule. So let's try it out. U is always the top of the fraction, and v is always the bottom. So if I write these out off to the side, u is x cubed plus 2x, and v is 3x take 1. U dash is going to be 3x squared plus 2, so that's just the derivative of u, and v dash is going to be 3. Let's plug it all into the quotient rule and see what we get. The quotient rule tells us the derivative is u dash v take uv dash over v squared. So that's 3x squared plus 2 is u dash, times that by v, take away, now we're going to get uv dash, so that's x cubed plus 2x, times by v dash, which is 3, and I'm just going to chuck that 3 out the front. Divide ourselves out by v squared, which is 3x take 1 squared. Now you can expand and simplify this, but most exam questions you'll see will just look like this, and it says don't bother simplifying your answers. Later on down the track, when we do multi-part problems, you will have to know how to simplify these, which is like foiling it out, then collecting like terms. Okay, let's do this one. So u is always going to be the top, and that's just going to be x to the 5, take 64. V is the bottom, which is square root of x, and I'm going to write that in as x to the half. U dash is 5x to the 4, and v dash is half x to the minus half. Beautiful. Okay, so the derivative, what do we get? Well, the quotient rule tells us u dash v take uv dash over v squared. So u dash is 5x to the 4 times v is x to the half, take uv dash, so that's x to the 5 take 64 times a half x to the minus a half, and on the bottom we're going to get v squared, so that's basically root x squared. Now the root and the squared will cancel out, so square root of x squared just leaves you with x on the bottom, which is a nice simplification for us there. Beautiful stuff. Okay, again, you might want to simplify that if you want to get fancy, but usually something like this is marked correct in an exam that just asks you to use the quotient rule. Next one we're going to do here, we already know how to differentiate this, so I'm going to go for our old method, which is actually better in this case. So y would equal x to the minus 1, so dy dx would equal minus 1x to the minus 2, or in other words, minus 1 over x squared. So that's the old way of doing it before we knew the quotient rule, and now we're going to do the quotient rule. Now the reason that I say the old way is better is because that's going to be a lot quicker, as we'll see. And quite often the mistake that students will make with the quotient rule is sometimes they use it when they don't need to. So if you can see something simple like this, you can often do it with index laws like we've done back there. But anyway, let's just try the quotient rule and see what happens. We get u on the top and v on the bottom. So u is 1, v is x. U dash, so derivative of 1 is 0 and derivative of x is 1. So if I'm going to go dy dx equals u dash v take uv dash over v squared, then that's going to give me, well, u dash is 0, lots of x, take uv dash, so that's 1 times 1 over v squared, so v is x. Cool. What does this all simplify down to? Well, the 0 times x goes away, so we get negative 1 over x squared. Oh my goodness, can you believe it? These are exactly the same answer, which is great because if they weren't, we'd be in trouble. So you can see the quotient rule there was a lot more difficult. So if you can get away without using the quotient rule, you do want to avoid using the quotient rule, because part of what you're being marked on in maths is not just whether you can get the answer, it's how efficiently you can get to the answer. And the way we kind of assess that is by making tests go for a particular time limit. So if you do stuff like this and use the quotient rule, where you could have had a more efficient method, you're going to be wasting that time.